8.2 is about arithmetic sequences and series. An arithmetic sequence, if you want, right above arithmetic, put down linear. This is a linear function, a linear arithmetic sequence. Is a sequence in which each term after the first differs from the preceding term by a fixed constant called the common difference. And we're going to use D for difference. You can also put under common difference, it's the slope. The sequence 5, 9, 13, 17, 21 is an arithmetic sequence since each term after the first is obtained by adding a 4 to the previous term. That common difference of an arithmetic sequence is D. So again, above D, if you want to put M for slope, then by the definition of the arithmetic sequence, D is equal to any two consecutive terms being subtracted, where you take the larger term in terms of its position minus the one before it. So you could go second term minus first, third minus second, fourth minus third, fifth minus fourth. So 9 minus 5 is the fourth, 13 minus 9, fourth. So you only need to do that once if you know it's an arithmetic sequence. So for example 1, find the common difference. Pick any pair. I'll take the first term 20, the second term 13. It is decreasing, which I can tell. Therefore, I know I'm going to have a negative difference. So 13 minus 20 is a negative 7. You could have done 6 minus 13, negative 1 minus 6, negative 8 minus negative 1. They'd all give you negative 7. Example 2, find the first 5 terms of each arithmetic sequence. The first term is 7. And the common difference is negative 3. Okay, first term is 7. Now subtract the 3. That would make it a 4. Subtract the 3. That makes it a 1. Subtract the 3 makes it a negative 2. Subtract the 3 makes it a negative 5. Example 2, part B. Same question, just shortened up with the notation. The first term is a sub 1 equals. That's the same thing. Okay, first term's negative 12. Our common difference is a positive 5, so we're adding 5 to the negative 12. That makes it a negative 7. Plus 5 is a negative 2. Plus 5 is a 3. Plus 5 is an 8. Next, if a sub 1 is the first term of a sequence and D is the common difference, then the terms of the sequence are given as follows. And what we're going to try to do is we're going to create an equation based on the first term and the difference only. So a sub 1 is equal to a sub 1. A sub 2 is equal to a sub 1 plus D. We didn't add anything to a sub 1 up here because technically that's my first term. A sub 3 is going to be the previous term a sub 2 plus a D. Okay, we said we wanted to create a pattern with just D's and a sub 1 in it. So I'm going to take a sub 1 plus D and replace a sub 2. Add the two D's, makes it a sub 1 plus 2D. If you can see a pattern starting to happen, fill it in. If not, we'll do one more, then you should see it. A sub 4 is going to be a sub 3 plus a D. Well, a sub 3 was a sub 1 plus 2D. Add this D to the 2D, makes it a 3D. All right, now I see it. This is going to be a sub 1 plus 4D, a sub 1 plus 5D. And there it is. Now, how to find my equation for a sub n? Notice when n is 6, I added 5Ds. When n is 5, 4Ds. N is 4, 3Ds. N is 3, 2Ds. N is 2, 1D. N is 1, 0Ds. So my formula is a sub 1 plus whatever your n is minus a 1 times your d. Or what I prefer, I like to have the d out in front. So this is the equation I'm always going to use. So using this for all my arithmetic sequences is going to be, okay, find the first term, find your difference. Or find your difference and then find your first term. Wait a minute, that's kind of like find your slope and a given point. That's right. This equation, remember we said it's a linear sequence function? This is the version of point slope in a sequence format. Example 3. Determine a sub 13 and a sub n for the arithmetic sequence -3, 1, 5, 9. Now, it's a trick question. Don't find this first. If you're going to do something like that, then on the test, I'm going to make this 113. I do not want you to come over here and go, oh, look, 5 minus 1 is 4. 9 minus 5 is 4. Oh, I'm always adding 4. Okay, I'm going to add 4s until I get to the 13th term. If you're going to do that, then I'm going to make it 213. You're going to add a lot of 4s. Always find a sub n first. Get that formula written down. Why? There's the first term. I just said 5 minus 1 is 4. That's the d. Or you can go 1 minus -3, whichever ones you want. But regardless, now I have my sequence function. And if I'm looking for a sub 13 or a sub 213, you just put 213 in for n and crunch the numbers. Okay, this one's 13. So 13 minus 1 is 12, times 4 is 48, minus 3, 45. There's the 13th term of that arithmetic sequence. And it doesn't matter what kind of information they give you, always start here. Find a sub n and a sub 18 for the arithmetic sequence having a sub 4 is 18, a sub 5 is 22. Okay, I'm all right with this. Start with this function. I wasn't given the first term, that's okay, we'll find it. But I was given two sequential terms, the fourth and the fifth. So if I subtract the fifth term minus the fourth term, I'll get my d. 22 minus 18, d is 4. All right, now, to find a sub 1, I'm going to use this right here. So I have my slope, and I have 2 points here. So a sub 5, if n were 5, a sub 5 would be 22 equals a sub 1 plus my common difference d4, and my n being a 5, n minus 1. The only thing left to solve for is a sub 1. 5 minus 1 is 4 times 4 is 16. Subtract the 16 over to the 22, I get 6. There's my a sub n equation. Okay, next, a sub 18, plug 18 in for n again. 18 minus 1 is 17. 17 times 4 is 68, plus 6, 74. All right, example 5. Suppose that an arithmetic sequence has a sub 8 equals -16 and a sub 16 equals -40. Find a sub 1. I need my a sub n equation because where's my a sub 1 is in that formula. Now, to find d might be a little bit more difficult because they did not give me two sequential terms here. So, wait a minute. I got it. Start with the 8th term, -16. And then I'm going to try to get to -40. Well, 8th term to the 16th term, that's 8 terms apart from each other. So -16 plus 16 minus 8 is 8. I need to add 8 d's to get to -40. So solve for d. Add over the 16, -24. 8d equals -24 divided by 8, d is -3. So that's how you can find your d. All right, a second way of finding your d, because it is technically the slope. I'll kind of put this over here so I can enlarge this. It's a slope. A sub 8 equaling -16, a sub 16 equaling -40 are technically 2 points. That's your n, and then that's your, if you will, a sub n or y. So, okay, stop. I'm going to think of this as this is my x, this is my y. This is my x, this is my y. I have 2 points. Now go find your d, which is technically your slope. second y minus first y. Second x minus first x. Plus plus negative 24 divided by 8. Okay, there's that right there. And then your difference is negative 3. So that's another way to find your difference, is thinking of those two given points as your slope. All right, well, again, pick a point to find a sub 1. I chose the second one. You can choose the first one. It's okay. So negative 40 equals a sub 1 minus 3. 16 is the n. Minus 1 is 15. 3 times 15 is 45. So minus 45. We'll add that over to the other side. A sub 1 is 5. So I could either write my function, sequence function, or we just had to find a sub 1. And we have that done that. All right, example 6, find the nth term from a graph. Don't panic. Don't panic. Write the formula for the nth term of the finite arithmetic sequence a sub n and state the domain and range of the sequence. Okay. There's my formula. I need the first term. Okay, that's when n is 1. I'll have 3.5. Okay, found a sub 1. Put that into my equation. Now find d. Well, all right, what's 2? When n is 2, I'm 3.0. All right, let's subtract this. Second term minus first term. 3 minus 3.5 is a negative 0.5. Okay, put that in for d. There we go. That's done. It's almost as if they're giving you the list of your sequence terms. 3.5, 3.0, 2.5, 2.0, 1.5, 1.0. And asking you to write the equation. They just put it in a graph. So my domain, please do not do the following. Do not use brackets from 1 to 6 because there's nothing in between those integers. You have to use braces and list the numbers 1, 2, 3, 4, 5, 6 and close it with another brace. Same thing with your range. And again, I don't care what order you put these in. If you want to say 3.5, 3.0, count backwards because it matches with the domain. Or if you want to put the range in numerical order, that's fine by me too. Just make sure you count every single y coordinate that we used. All right, so there's our sequences.